Greetings and welcome back to the lab, and welcome back to Musical Monday. I've been thinking about this project for the last couple of weeks in terms of what's the next step. And I've been thinking about the fact that I'm calling it the lab. Putting those two together, really what's happening is I'm getting a little bit... I'm trying to figure out what the next step is. And I know what my next step is now, but I'm going to need your help. What would be going beyond the oscillators themselves? What would be the next step? Would you like to see a delay effect? Would you like to see just some filtering? I've thought about various different ideas. And so if there's something out there that you'd like to see, I've gotten some parts and I've got some ideas. I'm also thinking about frequency modulation versus amplitude modulation. It's not just FM and AM on the radio. Those are actual principles that you could apply to sound. And in fact, that's how radio works, except that they're at a much higher frequency. So I thought about doing that. That would be kind of interesting to see what modulating these sounds would be like. Also, I need to build the bigger keyboard. I now have the circuit boards, the corrected circuit boards for this, so I can start building. But I think what I'll do is I'll do an episode on that where I'll build one oscillator and then just show you the stages beyond that. Building one oscillator, building one board, and then having a full octave, and then having the full 2-octave keyboard that I'm planning for the moment. You can go beyond 2 if you want. At one point I calculated that if you wanted every musical note that would fit within the range of human hearing, you'd have 12 octaves. An interesting sort of thought, and if you want me to cover my process on that, on figuring that out, I'll show you. But I think for this video, what we need to do is we need to go to what I'm going to be calling conditioner and output. So this is, I got another whiteboard just to help me deal with the content that's probably to come on this. But let me get rid of this real quick and explain why I'm thinking about this. Is that ultimately, no matter what module I add to this next, I need to have some standardization in this system. Something so that if you build your own module, you can have an expectation that the output will fit, the output of one module will fit certain parameters, so you can use those predictable parameters as the input to your module. Or in this case, whatever module I end up designing next. So I need a conditioner. I need to take the output from this, which even if I designed conditioning into this, it would make the circuit board much tighter, and that would be a problem. But even if I'd put it in there, I don't think this is the appropriate place to put it. I think the appropriate place to put it is to literally take, if you can imagine this circuit board, I'll put a render of the new circuit board for this up on the screen. But just before I do that, let me sort of say I'm going to talk about this sort of area right here, because aside from the switch interface here, this is where all my other interfacing happens. So I've got all of my connections for each individual oscillator up along here. All 8 of those are a direct output from the oscillator. Over on the sides here, I have input, output, and power, but the outputs are actually run through a sort of pre-mixing stage. And so I'm not sure whether I'm going to tap into the pre-mixing stage, or more likely I'm going to tap into the individual stages up here, because ultimately I want to have I want more control in order to do the conditioning properly. So that is where I am. The next step is ultimately going to be me starting to figure out how to condition the output signal. I'll be right back. So it's time to do some lab type stuff, and what I've done is connected the oscillator board to my oscilloscope and actually put it on top of a stack of boxes. Oddly enough, the stack of boxes that comprise the DIY Christmas lights project. So check that one out on Fridays. But here I've got this set up and I've got it hooked into the very first note. So I'll spare you the sound coming out of the speaker. This is a direct feed from the back of it here where I've got the tap off of the actual oscillator before it goes into the mixer. And so that is the resulting waveform that I'm getting, which is fairly clean. Now, one of the things I have to consider, if I hold that down, and I don't know how well this is going to come out, but you have the volts peak to peak on the right hand column at the top. And unfortunately, the way this is all laid out, the waveform is actually kind of running right through it. But it says basically about 3.3, and if I really want to, I can hit run, which will stop it, and then you can actually kind of focus in on it. So that is the output from that particular oscillator. If I run across all the oscillators, I actually went through this and wrote it all down. And the peak to peak, I'm reading off of a sheet here. I have for the C note, that's not matching up. Interesting. Oh. Okay, that's the max. No. Alright, I wrote something down wrong here, but right now, to line up with, I've got a sheet here, which it's going to be hard for you to read, to line up with the volts peak to peak there, it looks like the C note's coming in at 3.52, the D at 3.53, the E at 3.55, the F at 3.55, the G at 3.56, the A at 3.22, and the B at 3.46. So there may be an anomaly there with the B, but generally they're all coming in around 3.5 volts. Now, one of my goals here is going to be to get this signal conditioned so that I can use it for, initially I thought, okay, I'll just do everything as line in. But then it occurred to me, you know, if this is going to get connected to another synthesizer module or something, a URAC-based module, or I don't know. The question is, do I want line level? Do I want speaker level? Do I want instrument level, which I didn't even really know was a thing until I started looking all this up. And this is why this is kind of moving a little slowly right now, is because I have to do a lot of looking things up to kind of figure out where I'm going. But as it turns out, I could do all three. And that's, I think, what I'm going to do, is this new board that I'm going to create is going to condition the signal, but at the same time, it's going to give you three outputs in stereo. And then maybe in the future, on a future board, what I'll do is I'll set it up so that for all 8 oscillators on each one of these boards, you'll be able to go through and there'll be 8 potentiometers for you to actually adjust the stereo image. It's an odd thing to think about, but maybe there's an application out there where somebody really wants to fine-tune the thing so that their piano has the lowest note on the left and the highest note on the right, or if they really want to freak people out, the lowest note on the right and the highest note on the left, or some other weird image where you put the lowest note in the middle and the highest note in the middle, and somehow the mid-tones get spread out. Who knows? It just opens up possibilities for people. So it's a thought that I had. If that's an idea that you'd like me to pursue, please comment, let me know. But that's that one note. Now I could set it up for all the others and show you, but I've already done that testing. The other thing I tested was I tried to figure out the offset. Now, what happens here is this is coming up nice and clean right now. Sometimes, though, when I look at the waveforms coming out of this, it looks like they're going, the bottom of the square wave is actually higher than 0 volts. And that's called an offset. And I'm trying to figure out how to get that back down first so that I have a predictable waveform to work with. Once I have a predictable waveform to work with, I can then scale the, in this case, about 3.5 volts. I can scale that down to 1 volt and give it the right impedance, and that should then give me a line out. Instrument out and speaker, well, speaker out is basically going to just be the raw feed, but cleaned up. And instrument out is, I forget exactly what the voltage is, but we'll design that in there, and we'll set up the impedance to be right, so that if you plug it into another device, it will get, that device will get what it's expecting and be able to amplify or modify or whatever it's going to do. So that is really what I'm trying to do here, is get this, clean up the waveforms, make them predictable, and then scale them. That is what the whole conditioner part is, and as a part of that, just because I'm conditioning them to at least get one output, I might as well, while I'm at it, make sure that I've got line out in stereo and instrument out in stereo and speaker out. It's going to be hard to do stereo without actually having another board, but I can do a mixed version and output that in mono on a speaker, because there's no way I can predict what people are going to want in terms of which oscillators go to the left and which oscillators go to the right. Actually, now that I think of it, line out suffers the same problem, and so does speaker instrument out. So I'm talking about nothing here. They're all going to end up being in mono, but maybe what I'll do is I'll have a way of breaking it out so that I can have each channel give you a line out, an instrument out, and a speaker out, and be cleaned up. So that's the intention. Now let's tackle the first experiment, which is trying to make sure that it's predictable. I have now set up the speaker so that I can listen to what I'm doing, but also good test conditions, you're replicating reality, and in reality, somebody could have the speaker hooked up. But the other thing that I missed, and just realized as I was setting that up, was that on the oscilloscope I have this set up for AC coupling. That's why that waveform was so nicely centered. So now what I'm going to do is switch to DC coupling, and that's DC coupling. Let's see what it looks like now. Okay, it's not stable, but let's hold and see what we've got. Volts peak to peak is 3.37. That's close to the 3.52. The maximum is 3.47. The minimum is 0.10 volts. So really, peak to peak is the true measure of how tall this wave is, but the minimum is telling me what my offset is. So I'm at 0.10. That's not too bad. Let me try again. And repeat the test and make sure that your numbers line up. Here I've got my Vmin at 0.12 volts. Do it again. Vmin at 0.11. So I'm between 0.10 and 0.12. We're going to average it out and call it 0.11. That being my offset for this particular one. But when I tested it last night, I was at 0.8 of a volt, 0.8. That's a bit more than this is showing right now. So I need to kind of figure that out. But what I'm also thinking is, how can I get this to pull down, there's a hint, so that pull the entire wave down so that the bottom of the wave is at 0. And I have an idea how to do that. I need to test a few different things. Now last night, I tried a bunch of things last night just to get ready for this video. And one of them, I just took a random resistor and stuck it in there as a pull down resistor. That didn't seem to work too well, but it occurred to me that maybe the problem is my resistor wasn't a high enough value. So I want to try it with a higher value and see what happens. See if that actually does pull it down. Oh, there we go. These are 100K resistors, and I'm going to drop one in here. I have to reconfigure things a little bit. So I'm going to pause for a moment, and once I get it all set up, I'll show it to you. Now this may be hard to see, but what I've done is I've connected my oscilloscope. I've got the input to the oscilloscope. I've got my ground. This is the same as it was before. It's just connected directly to my power, because all of these grounds are supposed to be connected. I'm hoping that, I'm assuming for the moment that all things are equal and that I'm good there. What I've done is I've taken the input being the same input, but I put the resistor, and now I've tied the other end of the resistor to ground, which is this second pin over here on this output for this particular oscillator. So let's see if that makes any actual difference. Sound-wise, you're probably not going to notice anything. But if I go to run here, oh, now that's interesting. Without doing anything, everything's at about 3.4 to 3.49 volts. That actually looks more like it tied it to positive than to negative. So that is the first problem I'm having. Oh, wait a minute. No, I take that back. No, actually that is right. This is interesting. Well, let's see what we get. And hold. It's still reasonably square wave. My Vmax is at 3.47. My Vmin is still at 0.11. So it didn't solve the problem. And I feel like I'm missing something somewhere. So this is the part of the lab, is doing these experiments, trying different ideas to see what's going to work. Now I think what I want is I want some degree of resistance, but apparently 100K is too much. It's just, okay, actually no, now that I think of it, it may still be too much, but I'm looking at the wave and I'm realizing that the bottom of the wave is still at 0.10, 0.11, 0.12, somewhere in that neighborhood, whereas the top is at 3.47. I'll bet you that is almost the top output it could be, given, let's see, in a resting state, when I'm not hitting the oscillator, in a resting state, it's giving me 3.47. Let me try reconfiguring this to the second oscillator where I've got another one of these set of pins. And let's see if I can't just do this quickly. Of course, the pins and the sockets don't always agree with me, but that's because I'm going in and out a lot. I'm using these up a lot. So that should be the next key. And let's see. In a resting state, we're still at 3.47. And it's looking like we got the same thing, just a different frequency. My minimum is 0.12. My maximum is 3.47. Peak to peak, I'm getting 3.35 volts. It's about the same as the last one. What I'm trying to do is I'm trying to get the bottom down to 0. I thought a pull-down resistor would help, and it'll certainly keep it from wandering up higher, but I'm not getting rid of that 0.10. Now, the other possibility is that this 0.10 is just the oscilloscope. So I need to figure out, is this my problem? How do I ground? That's why I have the ground of the oscilloscope going to the ground of the power supply. What if I take another lead? I need to find another usable wire here. I think I got one here. Yep. If I take the ground from this side of the resistor and tie that to the ground so that I'm truly referencing the bottom side of this output instead of going to the ground from the power supply. Let's see if that makes a difference. Interesting. I am now down at 0.14, 0.15 without hitting anything. 0.14-ish. And wait a minute, how did I get... Oh, okay, yeah. How am I getting an output? Oh, my apologies. The speaker is hooked up to the mixed version of the output. It is slightly reduced in volume from what it was before, but it'll do all. But it will not show up on the oscilloscope, only the direct output that I've tapped into, connecting my probe leads, if you will, to that. Only that one will work, and that should be this one here. So, let's see. 3.47, 0.11, I'm right where I started. This is not solving my problem. Alright. At this point, the video is already getting long, and I've got a lot of this to figure out. So I'm going to start breaking this up, and if I can do some more of these experiments and get something released during the week, I will, but otherwise I'm just going to consider this a longer part of the series just to figure out this next part, this next board that I'm going to build. I'm going to do some more research. I'm going to start looking at parts and getting them ordered because I really want to do those output connectors and have the options of line out, instrument out, which is a 1/4 inch jack, and speaker out, which I'll come up with some more universal sort of connector that I can, instead of necessarily having everything bodged together like that. I'll come up with that, but in the meantime, I really could use somebody's help here. If you know audio engineering and you can see exactly, oh, you know, you missed this simple little thing. I mean, do I need to put a decoupling capacitor instead of a pull-down resistor? Should it be a pull-up resistor instead? Am I going to have to get inductors involved? I'm hoping not, because that just gets more complicated. I'm trying to keep it simple. There's got to be a simple solution to get this thing to bottom out at 0. And by the way, for those that might be wondering, why am I not trying to center the wave so that half of it goes above and half of it comes below 0? It's because the power supply is 5 volts. I'm trying to figure out how to do most of this on USB. If it turns out that DC will never work and I have to, or rather I should say, if a positive only power supply will never work and I need to have a positive negative, which I've seen in a lot of videos where people are building their own synthesizers and all of that, you know, they end up taking a 9-volt battery and putting it across a voltage divider or something like that. Actually, I don't know if that's enough voltage to drive a 555. Or go to 12 volts and you got 6 on the top, 6 on the bottom. Something. If I need to switch, then I'll have to redesign a bunch of stuff, or I'll design some sort of adapter board so I can keep using what I have. But I need help figuring out, A, how do I get this waveform down, and B, how do I make sure that I don't end up with weird spikes in my waveform? I want to keep it as close to a pure square wave as I can. I don't want to go completely crazy and have an nth stage filter. Actually, that would take it out of the square, but I don't want to have something super complicated because I want to be able to build this for each oscillator potentially. So I need your help. If you know what to do, please comment down below. If you want to find out more, please comment down below because there may be somebody out there who can help us figure all of this out. Meanwhile, I'm going to try and figure it out on my own, but I'm going to wrap up here. So thank you so much for watching. Take care of yourself. Have a great day.